because we do need 2 days of practice on this, I think. A very important skill is being able to read a graph and answer all of these questions in interval notation. So first of all, we're going to be partially learning interval notation and then partially learning what it means to increase, decrease, what it means to be positive, negative, and so on. So first of all, let's look at our domain and our range. Okay? Our domain is your list of x values. So what is the lowest x value this graph ever gets to? Haley. -3, 1, 2, 3. Very good. Now, does it actually reach -3 and include -3 or not? Is there actually a point at -3? Yes. Okay. Are you guys familiar with oh geez, I don't even have one on here. Are you familiar when endpoints of a graph, sometimes there'll be a solid circle, but sometimes they're an open circle? You're familiar with that. So in a case like that, it would be up until -3, but it wouldn't include -3. This one is a solid circle. So this one does reach -3. When that endpoint is included, you use a bracket in interval notation. So from the lowest number, comma, to the highest number, what is the maximum, Jack B, on your domain? Positive 6? 1, 2, 3, 4, 5, 6. Does it include that point?
Yes.
Yes. So it includes it, so it's a hard bracket. If it was an open circle, we would use a parenthesis. Okay? Yep.
What about, could we write it as -3 is less than or equal to x, less than or equal to
Well, you can, that's set builder notation, but this is specifically, we're kind of working on interval notation. Did we already touch on interval notation this year? My 3 classes just get so confused because your topics all overlap, so I didn't think so. So brackets. Have you done interval notation before in your life? Okay, so you're familiar with that. All right, now the range, you look at your y values. So the lowest this ever reaches is -1, 2, 3, 4, 5. -5. Is it actually hitting -5? Yes. And up to 1, 2, 3, 4. Okay? So that range, by the way, is one of the only times we care about the y-axis. From this point forward, when you're asked for the intervals along which this graph is increasing, you're kind of looking left to right, all x values. So other than the range, you're really not looking at your y-axis at all. And that's a common mistake. So increasing means just that. It's going up, right? It's got a positive slope. So if you want to write that, positive slope, you can. This is increasing from the beginning of the graph, which is at an x coordinate of -3, to, tell me when to stop my pencil. When does it stop increasing? Right there, right? Gets up to this maximum and it stops increasing. So you want to look at where that occurs on the x-axis. So it started at -3 and it's increasing up until -1. Yes? Now, is it still increasing at this moment? No. When it reaches the tippy top, it's neither increasing nor decreasing. And actually at endpoints itself, it's not actually increasing through that point either. So and this is just a general rule, anytime you're talking about increasing, decreasing, or constant intervals, you always use parentheses. Okay? So from -3 to -1. Does it ever increase again? Yes. Right here from -1, it starts to decrease And again, resist the temptation to look at your y coordinate. We don't really care how low it's going. We care from -1 all the way until here, which is an x coordinate of 1, 2, 3. From -1 to 3, it's decreasing. You almost want to create these lines. It's decreasing in between those. That's from -1 to 3. And then from 3 up until the end, it's increasing again. So that's at 3, 4, 5, 6. So from 3 to 6, in this interval, it's increasing again. So I go back to my increasing, and I use a union symbol. Have we done the union symbol in here? Okay. So anytime there's two different sections where something is occurring, we kind of adjoin the two of them with a union symbol. So write that at the top. Union. So that was, what I say, 3 to 6. And a constant would be any place where the slope is 0. So a flat line, which that's not actually occurring for any period of time. Do you follow? Okay? So we actually would just say nothing there. There is no constant interval. Like momentarily this has a slope of 0, but it's not a constant slope for any sustained period of time. So we don't worry about that. Now, positive and negative can be confusing with increasing and decreasing, because with increasing, we are talking about a positive slope. But when we're talking about where the function is actually positive, who can give me a feel for what they think that might mean?
When it's above the x-axis?
Right, above the x-axis with positive y coordinates. Okay, so this means above x-axis, and negative means below. So let's start with, well, let's just go left to right. This first section is below the x-axis, yes? That's from -3, and we're going to have to guesstimate. Where would you say that is approximately? Yeah?
Like -2.8.
-2.8, sure. So for -3, is it actually negative at -3? Is it actually below the x-axis? Is this point actually below the x-axis? Yes, it is. So that's going to be a bracket. From -3 to -2.8, we'll just use Bella's estimate. Whoever's phone is buzzing, please turn it off. At -2.8, is that actually below the x-axis there? No. So that's going to be a parenthesis. And then it's going to be positive. It's above the x-axis, starting with that -2.8 again, up until over here. Estimate, Chloe, for me what you think that x-coordinate is.
Probably like 0.8.
0.8, perfect. So from -2.8, where we left off with the negative, it's above the x-axis, aka positive, from there to 0.8-ish. Again, at 0.8, is it actually positive? No, because it's right on the x-axis, so we keep that whole thing in parentheses. And then we're negative again from 0.8 to where, Vince? Exactly 5? 5.2, perfect. Which again, we're going to use parentheses around because that's actually a 0. It's neither positive nor negative. And then after 5.2, so from 5.2 to 6, we're positive again. Not including 5.2, but we are going to include 6 with brackets this time. Because isn't this end point included and actually above the x-axis, so we're going to use a bracket there. Okay? Relative minimum points. Okay, there's relatives and there's absolutes. Okay, so let's actually do absolute first. Absolute means what is the lowest point on the graph, and that is right there. Do we all agree with that? That's an absolute minimum. That is the point, and it asks for a point here. So 1, 2, 3, negative 1, 2, 3, 4, 5. So 3, negative 5 is our absolute minimum. A relative minimum sometimes can be the same point, sometimes is different. Relative means that, just like that, relative to the points on both sides of it. So anything that's kind of like the bottom of a U shape, that is going to be a relative min, because relative to the points on the left and relative to the points on the right, it is lower than both of those. Do you follow me there? So our relative minimum point is still 3, negative 5. Now you're going to see a difference when we look at relative max in this particular problem as it compares to the absolute max, because they won't be the same. Where is the absolute highest point, Angie?
Negative 1, 3. Or no.
No. There's one higher than that.
6, 4.
Yeah, this one. Very good. That's the absolute maximum point. This absolute maximum, however, is not a relative maximum, because you can't say that relative to the points on the right side of it, it's higher, because there are no points on the right side of it. See how it doesn't actually turn around? It's not a turning point. Relative ones have to be turning points. So this one here, it's not the absolute max, but it still is a relative max because it's a turning point. And relative to the points on both sides of it, it is a maximum compared to those. So that negative 1, 3 is actually a relative max. And then our x-intercepts, we're just going to give the values for where it crosses the x-axis. We said negative 2.8, 0.8, x equals negative 2.8, comma 0.8. I'm just going to list them. And 5.2 were our estimates. And you only have one y-intercept, as long as it's a function. And that is at 2. So a lot of like nitty-gritty details to look at. So I'm going to give you your homework, and you just have to do 1, 2, and 3, but not 3B. Ignore 3B. 1, 2, and 3, but not 3B. Can't talk and count at the same time. You guys might be one short this whole session. Just let me know.